Actually, I suppose you'd probably love it if I gave you the Algebra 1 for today, but there we go. So we've got kind of a mishmash of things again today too, but they're all related, so it makes it quite a bit easier. So everything today is kind of based on properties of definite integrals. Okay, first property is the one I've got up there right now, and I use the word area a lot just because it's probably easiest for me to explain, but technically it's not area. The portion above the x-axis has a positive value. The portion below the x-axis has a negative value. And I don't think we've run into this yet. I believe we've only done examples with anything above the x-axis. So then that's kind of, this is just basically how definite integrals are set up. Again, I'll frequently use the word area, but area isn't correct to say because you can't have a negative area. So frequently the wording that you will see in a question is what is the value of the definite integral. And if your definite integral is above the x-axis, it's positive. If it's below the x-axis, it's negative. And you can have a combination of both. So like your definite integral doesn't have to be one or the other. It's just whenever your function is above the x-axis, you end up with positive numbers. Whenever it's below, it's negative. And you combine them together if you have like one large section, you know. So like this picture that I drew, the actual value of the definite integral would be awfully close to 0 because the positive section that I drew and the negative section are about the same size. So the final value of this one would be close to 0. There we go, shut that off. Does anybody have a question on that property? Okay, and then obviously that A, B, and C I have up there are just random made up numbers. Okay, second property, excuse me, should make a lot of sense. So if you have an integral going from A to A, the answer is 0. And no matter what number is in place of A, this should make sense because you're essentially moving nowhere. And if you're trying to find the area between nowhere, well, then there shouldn't be any area. Third property, and if I'm going too fast, let me know. So the third property is if you have a constant multiplier within a function. This works very much similar to limits. A lot of our properties for definite integrals are very similar to the properties for limits because a definite integral was created from a limit, you know, just like we went through last week. So if you have a definite integral of some number times variable things, then you can take that multiplier out front if it makes it easier for you or if it helps you find the answer. And I can certainly, where's my pen? There we go. I can certainly write an example of this if you want. Like the integral from -3 to 5 of 4x squared. That's equivalent to 4 times the integral from -3 to 5 of x squared. So whenever you have a multiplier like that, it is equal whether you put it on the function or multiply it out later. Okay, now this one doesn't necessarily seem super useful at first, but we actually use it quite a bit in a roundabout way. And what it says, if you have the integral from a to b, it's the same thing as the opposite of the integral from b to a. So what you're supposed to take out of this, if your bound numbers are flipped, the answer becomes the opposite. That's really all you should get out of that. Oh, what the heck. Now, I would also like to show you an alternative use of this property. If I scroll back up to this picture for a second, we basically always read left to right, right? Or correct? So, virtually everybody would read this as the integral from like 0 to 4. So let's pretend this is 0, 4, and 10, right? So the integral from 0 to 4 is how we traditionally read this. And looking at this picture, you'd have a positive answer. But if you don't read from right to left, so let's say we do the integral from 4 to 0. If we do the integral from 4 to 0, everything works opposite. So instead of getting a positive answer above the x-axis, if we go right to left, it would be a negative answer. And basically, this is the same as that property we just went over. If you do things in reverse, you get reversed information. It's kind of it. Same with this one. If I found the integral from 10 to 4, my answer would be positive instead. And so this is one roundabout way where we can use that property of flipping the bounds. I better erase this, otherwise we'll think that's part of it. Okay, so that was 4. The fifth property, very well might just make logical sense to you. It basically just says if you have an integral of, where'd my pen go? There we go. If you have an integral of multiple functions, you can evaluate them separately. And this is exactly like we had done with limits. It's like we had done with derivatives. Addition and subtraction is an operation that frequently can be separated, because the whole point of the operation is that they are separate things to begin with anyway. So, if you want me to write an example, if you have the integral from 2 to 5 of x squared minus 3x plus 2, you can separate them. I mean, like, I don't know why this would make it easier, but if it could, this is essentially what you could do if you wanted to. Like, this absolutely takes a lot longer writing. But this kind of tells you what you're going to do mentally. So when we get to the point where we're going to evaluate things, you just know that you can evaluate all the terms individually. And then the last property, it makes sense and most people get it. The hardest part of this property is the fact that how they choose their variables. And this is how every calc book I've ever seen write this property writes it. It basically says that if you have an integral from a to b, it is equal that if you pick any random number between a and b, which in this case they call c, that's obviously the part that bothers me. So c is a variable between a and b. You can split up your integral into pieces. So the integral from a to c and the integral from c to b is equal to a to b. So this is the one that talks about if you have adjacent definite integrals. So they would have to literally be right next to each other. But yes, I don't like the fact that c is between them. Okay, I don't know. So these are the properties we are pretty much going to base most of all of our workings of integrals from. They're fairly straightforward, but it's also easy to forget properties as you're doing problems because your brain is kind of focused on all this difficult stuff and you kind of forget how the properties are set up. Do you guys want me to cover or go over any of these properties with you? I'm hoping you have 1 through 6 written down. I don't know if you guys can hear the cat snoring, but it's loud enough that I can hear it through my headphones. It's a cold day, so I had the fireplace turned on. Basically a cat heaven. Well, then let's kind of start doing some problems together and talking about how we could use the properties to help us figure things out. So what I've got up on top in green was exactly like the problems we did, I believe, on Friday. Everything kind of starts to blend together here, but I think it was Friday. So this was the second fundamental theorem of calc, when you take the derivative of a definite integral with variables as one of the bounds. You know, very specific situation. And this says 3 plus t, which I realize now that I'm looking at it now, the plus and the t kind of look the same. I usually try to make my t have a tail, just for that reason. But the derivative and the integral symbols cancel each other out. And your answer is going to be this variable function plugged in place of the variable that was there. So plug the x to the 4th in place of t and dt, and you get 3 plus x to the 4th times 4x cubed. That's what we did Friday. You guys are being awfully silent today. Are things going well, or is this just... I don't know, you've got no reason to be down. It's super nice outside. It's supposed to be 40s and 50s here for like the next week. That would definitely get me pumped up. But it's a good reason to be quiet. Yes. Yeah. Caduce. Yeah, it is a Monday. Caduce, this pink one that I have written down below, how is this pink one different than the green one up above it? I see you're trying to talk, but it's not actually coming through. That's all right. Okay, we didn't need details on the burrito bowl. Ellie. Yeah, it's okay, Caduce. It's not working. Yeah. Oh, the variable and the number is flipped. Perfect. Yep. Please don't make me mute you guys over a burrito. I am more than a little worried that you got very sidetracked over food, especially since you guys have already eaten lunch. Wait, do you guys wait to go home to eat? Oh my God. I'm getting very strong vibes of the dog from Up right now. Every single person here. Squirrel? Squirrel? Okay, so Caduce told me that the variable's on the bottom instead of top. Jack, what property are we going to use from above to make the variable be on top instead? I actually have no idea which numbers is which. Which one's the... Perfect. Okay, so how would I write this instead? Yep, negative the derivative of integral of 8 on the bottom, x cubed on top. Very good. Very good. So we basically went over how to do this with variables on the top. I need to scroll down. Natalie, how would I get the answer to this pink one? Well, I don't know what would be easiest. Is it easiest if you just tell me the answer, or? Otherwise, I can walk you through it. Okay. So obviously the negative is just going to go with the answer. And if we're taking the derivative of an integral, they cancel out. And then we're going to take that variable information and put it in place of the t's. Do you kind of remember doing that Friday now? Okay. Oh, okay. So then what would be the answer when we're done? Where'd the 24 come from? Gotcha. There you go. Okay. Excellent. I know, my handwriting's not always great. Okay, we're going to move on to the same question but harder. The one written in blue. So I am asking to find the derivative of an integral, but both spots are variables this time. So off on the right, I put a property that we can use to kind of make it workable. So the property I put was that we can take a single integral and split it up into two by choosing a number between them. Now the part of this that doesn't seem doable is like, how do you figure out a number between square root of x and x squared when you don't know what they're worth? And that's actually the easy part, because you don't have to. So it doesn't matter what number this is, because it's not going to be part of the answer. So what we're going to do is we're just going to pick C. Pick a number between them. Yeah, I wanted to make sure I read all the variables right because there's so much stuff going on there. So what I did was I just kind of said C is a number between them. And I don't care what number it is, it's just between them. I'd like you guys to try to find the final answer for this. See if you can come up with the final answer for this problem. Let's see. I'm going to put Jackson in charge of this one. So Jackson, whenever you get the answer from that first one figured out, you let me know. And let's put Maddie in charge of the second one. I think it's IE, right? That looks like Mad Pie. I need better writing. So whenever you two come up with the answers for those parts, let me know, and I can certainly help you or walk you through it if you need some help. Maybe. Are you guys there? Jackson or Maddie, are you there? Oh, that's fine, Jackson. I don't mind helping anybody too. I mean, like if you get called on something, you guys, if you guys don't know, there's like no shame in saying that. So, okay, so Jackson would like some help. Can somebody help him with the first one? I'll just say anybody. Are these like much more difficult than I was expecting? C squared, okay. Ooh, nice. We got two people with the same answer. Okay, let's find out. So the first thing I notice is that the variable information should be on the top. And you guys will find out later why it should be on the top. For now, it doesn't matter. But to put the variable information on the top, we're going to have to reverse the two pieces and make the whole integral negative. And then I'm going to plug square root of x in place of t. So we've got square root of x squared times the derivative of square root of x, which is 1/2 x to the negative half. And if I simplify that, I've got negative square root of x squared is x. 1/2 x to the negative half I could approach this a bunch of ways. What I'm going to do is I'm just going to add their powers. Because this is x to the first times x to the negative half, so I can add their powers. And so this is going to become negative 1/2 x to the half, or square root of x. That's the first term. Oh, I did not even put that together. You guys treated c as a variable. C is a number. C represents a number. I picked a number between square root of x and x squared. I didn't even put that together. Maddie, how about the second one? Were you able to come up with the second one? I'm thinking we should call on somebody else because I don't think Maddie can hear or whatever. Haley? Haley, did you figure out the second one? Good. Very good. So the number's on the bottom already. So you are able to just take this and plug it in place of t. Oh, that's fine, Maddie. I mean, like I said, if you guys don't know the answer, just let me know so we don't just sit there and wait in silence. Like, I just didn't even know you could hear me. Yeah. Right here. Oh, you mean the final answer? Oh, yeah. So this is like saying negative 1 times x to the first times 1/2 times x to the negative half. And if you multiply two of the same base, you can add their powers. So I just did 1 plus negative half. Yeah. Gotcha. That's no problem, Maddie. Like, I'm not. Yeah, I mean, I'm not mad, and I don't take it personal. I just was just trying to teach efficiently. Okay, so this is really all I had on this topic. This was basically just left over from Friday. So I didn't want to do these two problems on Friday because we hadn't talked about the properties to be able to do them yet. But otherwise, these were exact same as Friday's setup. You just needed to know some properties to be able to start them. And then this is going to be the next type of questions you're going to run into, where you'll be given a picture and then just asked to find the answer using properties. So, Ari, do you think you could help me out on this question? What is it asking? Okay, from where to, like, if you could read that off, that would be awesome. Because I know some people need help knowing how to read that. Okay, good. It's 0 to 3. But yes, yep. Well, that's all right. So it wants these two areas. Now looking at what I drew badly on, those two areas are right next to each other. So what would you say the final answer would be? Yeah, that's it. So because they asked us the two areas that combined made negative 2 to 3, and this picture showed us that negative 2 to 3 was equal to 7, that's all we do. I mean, this 7 definitely was not supposed to represent on the right-hand side or anything. It's that whole blue section. And you're going to get a lot of questions that use the same pictures, so we're not always going to use the whole picture. I mean, like you might have the same picture for 3 questions in a row, and they'll ask you different things about it. But we're going to try to use our properties to figure them out. Very nice job, Ari. Elijah, I know you don't have a mic, but I was hoping you could kind of type this one into the chat, because this one's probably an easy enough one to type in the chat. How would we figure out this one? The integral from 0 to 5 of -2 times f of x. Perfect. Perfect. So Elijah says you put the -2 in the front, so I'll start by doing that. So I'm going to do -2 times the integral from 0 to 5 of f of x. And then if I look at my picture, the integral from 0 to 5 has an answer of 4. So my answer would be -8. It is really easy to overlook that -2. That's a mistake that I will see on a test a lot. Just because you're so focused on the 0 and the 5, that it's really easy to not, like your eyes, not to see that -2. That's really the main reason I wanted to put this example up. Here, why don't you guys try these two? I mean, along the same lines, different properties, different uses. Just try these two. Let's see. Let's give this one to Johnny. And this one to Dane. Whenever you guys figure them out, or if you need help, let me know. Okay, Johnny, I was going to say yours is... Oh, I'm a little behind because I was... Got it. Yes, you're definitely going to want to... Yeah, I mean, I'm sure whatever reason you were gone for is... But yes, if you guys are ever gone a day, you always want to try to watch the video or, whatever before the next day starts, because it's so hard to catch up in here. And it's just the way Calc is set up. It's not something that I like. It's just how it is. But yes, that's all right, Johnny. So basically anybody, this answer should be take you half a second. Or Dane, looks like Dane has your answer. Yeah. Close. The reason this one is considered different is because it's backwards orientation. So you're asked to find the integral from 7 to 4 instead of 4 to 7 would be the normal way. So because they're reversed, your answer would be, yeah, yep. Yeah, no, very good. That's why I wanted some of these examples up, just so you guys could see what happens when you run into them. But yes, this one, it doesn't even matter what the picture is. The answer is 0. These questions are like golden on the test, because you see it, you know the answer, and they take 0 time. Okay? Different style question, same things. These first two are like givens. So on a test or something, it would say, given this and this, find this. So we know that the integral from -1 to 3 of f of x is -2. We know that the integral from -1 to 3 of g of x is 5. Find the integral from -1 to 3 of 3 times f of x minus 2 times g of x. And once you get comfortable enough with these, you basically should immediately be able to do 3 times -2 minus 2 times 5. Because you know that this is -2 and this is 5. So what do we get? -6 minus 10? -16. These problems today are generally going to go very fast. It's more the fact that, I wanted to go over them with you guys because otherwise you're just not even sure what it's asking you to do, usually. These are the ones that can be confusing when you run into them out of nowhere. Why don't you guys see if you can figure out this one kind of quickly. Oh, go ahead. Do you still need to do the dx at the end? No, you don't actually. Once you integrate, the dx goes away. I believe that's tomorrow's lesson when we start learning how to actually integrate. But see if you guys can try this one on your own. So it may not be obvious to you at first, but the first thing that caught my eye was that these all had different numbers, but yet it was the same numbers in different combinations. So it kind of immediately brought to my mind that I looked for the smallest number, and then I looked for the biggest number. And this bottom one is the one that had the smallest and the biggest. And then 1 is in between them. So what I did, and this is obviously scratch work because this is in no way official writing. What I did was I write it down to myself, like in order. And then I figure out which one is missing. So we were asked to find this one. We were given the answers to these first two. And so this is what we're doing. Now, this question is straightforward, but I want you guys to know that any one of these three you're going to be asked to find. You're not always going to be asked to find the answer, like the third one, the equals. You very well might be asked to find, like, say, this one. And then you'd have to do subtraction instead. And so that's why I just kind of wrote this question out, because this is 100% the type of question you'll see on the AP test rather than the one we just did as an example. AP usually likes to take every normal question and write it in a weird way. Okay, what I would start with, I see that they're all different numbers again. So I would look for the smallest number and the biggest number. Smallest number is -5. Biggest number is +5. So this middle one is the third. So if I were doing scratch work to myself, I would set it up this way. So -5 is where I would start, and +5 is where I would end. So this is how I could set it up using that property. And then I'm just going to put the numbers in place. So 2 to 5 is 11. -5 to 5 is -2. This is the one that we don't know. So I would subtract 11. And then -13 is the one, is the final answer. Like, this is absolutely how I'd recommend setting it up to you guys. Because over the years, I see a lot of people trying to do these in their head and have a completely opposite answer because in their head they had it backwards. So like they might come up with +13. Yeah, it 100% is that simple. It's not that simple if it's not explained to you at first. Like if you were just given this question, they definitely, it feels really complicated because it's just a lot of facts. But that's all there is to these questions. Today is all about the properties. And so I have a feeling you're going to fly through today's information, which for a lot of you is good. It's going to feel kind of like a breather, you know. Like last week's information was really hard to follow, and the questions went really slow. You didn't have a lot of work, it just went really slow. Now the beginning of this week, you're going to find that the questions are easy to do, but you're going to have a lot of work, but it goes fast, you know. So it's going to be like an equal amount of work. It's just they're going to go a lot faster and kind of easier on your brain. So in Khan Academy, you should be able to do these 4 topics now. Just after today's. Like we didn't even cover that much information today. Like, although I guess it's already almost 1 o'clock. We didn't cover that much information, but it's a lot of different styles of questions, and so it's a lot of different homework. In preparation for this week, so I put it on the weekly calendar in Schoology, and basically Monday through Thursday, we're going to finish up all of the material for Unit 6. And I'll basically think about this, like, you know, like I'm not just going to teach this information to you, like, just to fit it in, right? So I'm going to make sure everything is going okay and things like that. I'm not going to just shove it in just to get where we need to be. And then Friday is obviously our test. You know, like there's not really any way around that. Friday's the last day of the trimester, and your spring break starts after that. So there's really no question about, like, that's the test. In brainstorming, what I thought I might do is we normally take a class day to go over the outline. I thought I might do Thursday afternoon. Like, normally I have my open help hours, you know, after class. I thought what I might do is do that on Thursday, and then just basically answer any kind of questions you have on the outline, you know, like, I know some of you are worried about getting home, so I'll just do it till later, you know, like, I'll just go till 3 o'clock or something. Just, like, answer any questions you have on the outline. The outline is already attached to the weekly calendar. What I will say is the information that's on the outline is the biggest the test would be. So it's entirely possible we might not make it to definite integrals with U substitution. And I know you don't know what that is, but so if that's the case, I'm going to take it off the test. I'm not going to just, like, this is what I was trying to say. I'm not just going to fit everything and cram it in just because the test is Friday. We'll get as far as we can, and then however far we get is what you'll be tested on. That's how I'll put it. Will we have a review day? I think we'd be better off going over lessons on Thursday, and then doing the outlines separate, which, I don't know, it's better or worse. That's just kind of what I thought. The test due at 11:59. No, the test will be due by 3 o'clock on Friday. So it'll have to be due before the end of the school day on Friday. I can record the Thursday afternoon session. That's not a problem. Should we still do it on Schoology? Like, do you mean the test, Finley? Like the test is in, do you mean Khan Academy, I think. Yeah, no, that's a problem. No, if we're not able to get to everything, I'm not going to expecting you to do it on Khan Academy. Shoot, that brings up a good point about Khan Academy. I imagine I have to take the scores. I'll probably put your Khan Academy scores in while you're taking the test on Friday, I guess. I can't think of a better way. It'll be live, Julia. You can start it whenever you want. I'm going to be on Zoom from 12:10 till 3:30, and then you guys, I think it's a 90-minute time limit. You can just come on and start whenever you want, but do it live while I'm on. Is the test going to be live? How are you going to grade Khan Academy? Well, I have to find out how far we get in the unit before I worry about Khan Academy, I guess. Well, what do you mean, Tara? Like, do you have other classes that you have to test in the afternoon for? No. Like, you can come on when we normally meet third hour. But yes, but then you can continue past that if you want. Yeah. Oh, okay. That's what I was confused about. Yeah. No, that's the only reason I set it up that way, because I thought that should be okay for you, given that that was last hour of the day. I don't know. Is anybody going to be gone early for spring break? I hope not. Yeah, Vincent, that would probably be the only. Here's what I'd recommend, actually, Vincent. So if you if you have a Chromebook or something that runs really slow, it might actually be beneficial for you to use your phone. Like, you can just prop your phone up and, point it at you taking the test. And that, yeah, you could do the Zoom on the phone. And then that way it shouldn't affect your test at all. Like it won't slow down your Chromebook or something like that. And I know that won't work great for everybody. But the people that did that previous trimesters, I think they preferred that just because then their Chromebook didn't get slowed down or, didn't mess with their work. I will go look, Ellie. I can't remember if you have to upload any work or not. I know this test I want to say there were questions where you type the work in the question. How about if we have other test work after third hour on Friday? Well, if you take, oh God, Friday. I was thinking we start at 12 o'clock on Friday. We don't. We start at 11 o'clock. Well, if you start my test at 11, you'd be done by 12:30, because I want to say it's a 90-minute time limit. I'll go double check all that. Would that still work for you, Caduce? So that you'd have from 12:30 to 3:30 to do the other classes? I was basically just trying to brainstorm. Like I know it would work best for you guys to take it Thursday night, but I wasn't really sure. Like, I didn't think anybody would want to, I thought you might feel too rushed if you took the test Thursday night. Yeah. Well, I'll be honest, if you guys do it Thursday night, I don't particularly feel fond of sitting on my computer all Thursday. Do you guys have a preference? Like, would you guys rather take it Thursday night? I just have to have everything in by the end of the school day Friday, so that was kind of... I assumed most of you would prefer to take it Friday. I just... Because I kind of have to have an all or none deal, unfortunately. Okay. All right. Well, I'll try to think about it. If I can come up with, some kind of options for you, I'll do that. If I can't figure out a way to do options, then obviously it'll just be Friday, 11 o'clock till whenever you get done. But I'll try to think about it then. Okay. Well, I guess I'm done with notes for today. I really wanted to give you a heads up for this week so that you didn't feel like everything was thrown at you at the end of the week. I'll stay on here to help you guys with any questions you want, but you're welcome to kind of leave the call whenever you'd like, and get those 4 assignments done in Khan Academy. Definitely don't fall behind in work this week, because otherwise the end of the week is going to feel too stressful for you. So, I'll end the recording too.